How are you guys doing? So, we will do today a problem that's related to energy conservation of energy. Okay. So, this problem um, states that what minimum speed does a 100 grams puck? I don't know how to say that. So it's puck or puck. I don't know, but it's that stuff that the hockey players plays with, right? So there is a puck here, okay? And what is the minimum speed? So he's talking about velocity, right? Speed, V. That need to make it to go to the top, need to make it to the top of a frictionless ramp that is 3.0 meters long. So, and incline it at 20 degrees. So what minimum speed does a 100 grams puck need to make it to the top of the frictionless ramp that is 3.0 meters long and incline it at 20 degrees? Okay, so this problem here is for algebra based physics, right? So what we are talking about here is conservation of energy. So as a conservation of energy, you remember that we can use this specific equation here, right? Look, this is our equation. So the we know that the conservation of energy will be equals to zero. That means the sum of all variations of all energies in this problem here will be equals to zero. When I talk about variation, will be delta K. It will be the final kinetic energy minus initial kinetic energy. The final potential gravitational energy, initial potential gravitational energy. But this problem here, guys, we can cancel, to be honest, we can cancel the thermal and the spring, right? Because we don't have both. Because thermal, it states here that it's frictionless. So that means we don't have friction. If we don't have friction, we will not have thermal energy. We don't have any spring here, so we don't need to use that. So what we need, what we know that we're gonna need, it's these two guys here, kinetic and potential. Well, but if you remember, um, all the energy is changing, right? It's changing from one, for example, from kinetic to potential and potential to kinetic. So if this puck it needs a certain speed here, v, right, this direction, and we need to calculate, that means we know that this guy is, if we set our reference right here, y and x here, so we know that he goes up. That means he will increase his potential energy. Can you see that? He will get some height here. So the question is, what is the velocity, speed that this guy needs to get up here? Well, we can treat this problem as a conservation of energy. How we can do that? We can state that, okay, so the total potential energy here, it will be equals to the necessary kinetic energy that this guy must have to get here. So to be honest, my final potential energy will be equals to my initial kinetic energy. But let's talk, let's put that in math, right? As math. So what that means is my the variation of my kinetic energy plus the variation of my potential energy will be equals to zero. That leads to, okay, so let me write down everything. 1/2 of mass final velocity minus 1/2 mass of initial velocity. Now plus mass gravity final height minus mass gravity initial height equals to zero. Do you agree? It's just this equation here. I open up every single one. So as I told you guys, Well, my initial, let's do it here. So my final velocity when this guy gets in this position here, this guy will have velocity equals to 0. So I can goes to 0 here. Final velocity equals to 0. You just need to remember that's the same thing when you throw a ball up. The highest point will be velocity 0. Okay, so initial velocity, so this is what I need to calculate, okay? And what is my initial height here? Well, if this puck is right here, this on the x-axis with the 0 height, so this guy, guess what, will be 0 here. Makes sense? And this guy here, I mean, I can calculate. I will show you how how I can calculate this guy here. It's going to be really simple because look, to calculate my final height, guys, who is my final height? If I have the hypotenuse here and the angle, now this guy here will works as an opposite angle. So this guy, we can use the side, right? Because if you remember, if we have a triangle like this, theta here, so this is the hypotenuse, this is the opposite, this is the adjacent. So my sine of theta will be the opposite. Oh, I'm sorry. The opposite, not the theta. The opposite here, right? The opposite here. If this software obeys me, he is not obeying me. So this is the opposite over the hypotenuse, right? So that means my final height here, h, will be equals to my hypotenuse, right? That means 3 meters times what, guys? The sine of theta. That means 20 degrees. Make sense? Okay, so I can calculate this really easy. Let me get here my calculator. So let me get here. So look, gonna be 3 times the sine of 20 degrees. This will be 1 point. This is going to be 1.03. Okay, we can approximate that. So it's going to be 1.03 meters. Okay, awesome. So what we need to do now is, look, we can just plug it in this guy right here, and we can do algebra now because what we're gonna have will be mg final height equals to 1/2 mass initial velocity. So we just send this guy to the other side of the equality. Every time when we move one thing, one variable or number from one side the equality to another side, we change the sign, right? So you know that I love to do what I'm gonna do right now. It's cancel the mass because we have mass in both sides. So now what that means gonna mean will be like, okay, so the velocity will be 2 times the gravity and the final height. That will lead that my initial velocity will be square root of um, will be square root of 2 gravity and final height. Well, let's calculate that. Let's plug it in the numbers. So it's going to be 2 times 9.8 meters per second square times 1.03 meters. Agree? And this will be square root of everything. So the initial velocity, so let's calculate. Let me get my super hyper calculator here. So it's going to be 2 times 9.8 times 1.03. That will be 20. Whoa, 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 whoa. You see, we can always make some. So this is not 20. My eraser is not working. So this is going to be the square root of this number here. So it's going to be 4, the correct number is going to be 4 point, we can say 5 meters per second. So this will be the final answer. So just remember what we did. We make the drawing. This is very important because you're going to visualize everything here. We understood that the puck will come this way and will get the highest point. At the highest point, the velocity will be equals to 0. So the velocity equals to 0, that means we can cancel a lot of things, right? The final velocity. So we put all the equations here that we're gonna need because we're gonna use conservation of energy. So we can put like the variation of kinetic energy here plus the variation of potential energy. We just plug it in the numbers. We realize that the height here is just the opposite, the opposite line of the angle. So we can just calculate using trigonometry, and boom, we have our final, the initial velocity that this puck needs to have to go to the top of this ramp. Okay, so I hope you enjoy it, and let's do physics. Let's do physics, guys.